welcome to mechanical major. In the last class we have discussed about the magnetic properties, magnetic terms in the magnetic circuit topic. आज की जो क्लास होने वाली है वह है हमारी types of magnetic materials and also the BH curve, which is very important for your prelims as well as mains examination. तो चलिए स्टार्ट करते हैं आज का वीडियो. See friends, types of magnetic material, if it will be asked in your examination, then you have to only read about the properties, the types and their examples. Nothing more in that. So I have briefed this in this lecture और इसी को हम आज देखने वाले हैं. So there are 5 types of magnetic material, you can say. The first one is the ferromagnetic material, second is paramagnetic, third is diamagnetic, fourth is magnetically soft material, and the number 5th is magnetically hard material. In that also these first three are very important. So let's discuss all. First one is ferromagnetic material. Now in this ferromagnetic material the magnetic property is very high. It is highly attracted to the magnets. If a ferromagnetic material is placed here, then it will be highly attracted to the magnet. Okay, so permanent magnetism can be induced in it because it is very highly attractive to the magnet. Okay, and the relative permeability, that is mu r, is greater than unity or 1. So mu r is greater than 1. Okay, and the susceptibility is very high. We will see this susceptibility in the BH curve. Okay. Now, if I talk about the magnetism or the induction, so it is aligned in single direction. The molecules of the material are aligned in single direction and highly centered. The lines will be towards the center, you can say. Okay. So examples, if we talk about, so examples are iron. Of course, iron will be there. Cobalt, nickel, chromium, and manganese. And application, if I talk, where they can be used, so they can be used in magnetic recording devices. So in tape recorders or the magnetic recorders, you can say. Also in floppy disks that are used in computers in the recent past, and credit card stripes. The credit card which you contain, in back side there is a magnetic stripes. Again this is replaced by the EMV cards, EMV chips, sorry. So this is also a recent past technology. So these many applications you can be, it can be used. Now we talk about the paramagnetic material. So paramagnetic material is weakly attracted to the magnets. So if a material that is weakly attracted to the magnet, then can we make it a permanent magnet? No, because no permanent magnetism can be sustained or can be retained by these paramagnetic materials. So they can't be used for making permanent magnets. Now if we talk about the relative permeability here, then it is slightly greater than 1 instead of the very much greater than 1. So it is slightly greater than 1, you can say. And last is attract lines of force weakly. Here the lines of forces are attracted strongly and they are concentrated towards the field. But here you can see the lines are very weakly attracted. If they are strongly attracted, then the concentration will be in this area particularly. And if we talk about the magnetic arrangement, so there are random arrangement in the material, you can say. And the examples are aluminium, that is Pt, calcium and oxygen. So these all are the paramagnetic material. Now we talk about the diamagnetic material. So diamagnetic materials can be created if we apply a magnetic field to a material, and if the direction of the field induced is opposite to the magnetic field applied, then we call it as a diamagnetic material. Means in diamagnetic material the induced magnetic field is opposite to the applied magnetic field. This you have to remember. And susceptibility is negative. We will see the susceptibility in our BH curve later. Be with the video till watch till the end. Then if we talk about relative permeability, it is slightly less than 1. Here it is slightly greater than 1. Here it is slightly less than 1. and repel lines of force slightly. So lines of force are repelled slightly. Okay, it is attracted slightly, and here it is repelled slightly. Means the lines of forces will be opposite. Okay, it will not come to the center, rather they will go away from the center, because it is repelling the lines of force, not attracting the lines of force. And if you talk about the examples, then bismuth, silver, copper and hydrogen are the you can say diamagnetic materials. And the last one, if we talk about the application of diamagnetic material, so it is highly used in magnetic levitation. And what is a magnetic levitation? It is used in transports, especially the railways. A magnetic material is slided over a high magnetic field. Okay, they don't be in contact, but due to magnetism or due to, you can say, repulsion, the magnet field, means अगर ये ट्रेन है और उसके नीचे हम मैग्नेटिक फील्ड बना देते हैं, तो वो क्या करेगा, एक दूसरे को रिपेल करेगा, तो वो बहुत आगे हाई स्पीड से वो चलता है. तो दैट इज कॉल्ड एज मैग्नेटिक लेविटेशन, ट्रांसपोर्टेशन, यू कैन से. नाउ वी हैव टू मटेरियल दैट आर one is magnetically soft material and one is magnetically hard material. So as the name suggests, soft material means the permeability will be very high, because it will allow the lines of force to from itself, and magnetic energy stored is not high, so storage is not possible, but the permeability is very high. Now hysteresis loop is low, narrow, you can say. The hysteresis loop is narrow, the area of the loop is narrow. We will see it here in some time in this lecture only. Now if we talk about the magnetically soft material examples, so the examples are ingot iron, cast iron, manganese and nickel steel. So ingot iron is a special type of iron. You can see it in steel plants manufacturing process. If you talk about the syllabus, so you will find that ingot iron, cast iron, then cast steel, stainless steel, these all are the varieties of iron, you can say, or you can say that there are various types of irons which are used in various fields. So the application of magnetically soft materials are, they are used as a electromagnets. Now electromagnets क्या होते हैं? Electromagnets वो magnets होते हैं जिन magnets पे जब तक इलेक्ट्रिक फील्ड अप्लाइड रहता है तब तक वो एज अ मैग्नेट बिहेव करते हैं, एंड आफ्टर द रिमूवल ऑफ इलेक्ट्रिक फील्ड द मैग्नेटिज्म इज लॉस्ट. सो उनका जो यूज होता है इलेक्ट्रोमैग्नेट्स का, वो कहाँ होता है? तो बेल्स में, लाउड स्पीकर्स में और भी ऐसे जगहों पर. ठीक है, यहाँ पर आप देखेंगे कि कहीं कहीं मैग्नेटिकली सॉफ्ट मटेरियल जो है वह ट्रांसफॉर्मर्स में भी यूज किया जाता है, ड्यू टू इट्स वेरी गुड प्रॉपर्टी ऑफ परमियंस, एंड ड्यू टू द अल्टरनेटिंग नेचर ऑफ द फील्ड देयर, इट इज हाईली यूज्ड इन ट्रांसफॉर्मर्स. सो टॉकिंग अबाउट द लास्ट वन, दैट इज मैग्नेटिकली हार्ड मटेरियल. It has high value of B into H. B into H means the product of the flux density and the force. So BH is very high there, okay, and high coercivity. Coercivity we will see in our BH curve. If you have certain terms like coercivity, or you can say the susceptibility, we will see this in the BH curve in following time. Okay. Hysteresis loop is more rectangular in shape. The loop is more rectangular in shape. So hysteresis loop is not narrow, you can say. Okay. And strong magnetic reluctance. We had seen in the last class what is reluctance. It is just as same as resistance in your electric field. So the strong magnetic reluctance will be here in the hard materials. If we talk about the examples, so cobalt steel, chromium steel, etc. are the examples, and the application is the very important application ki they are used for making permanent magnets. So permanent magnets are used or are made from the magnetically hard material. So this is all about the types of magnetic materials. Now we learn the BH curve. Now let's talk about our BH curve. It is also called as hysteresis loop. Now हमें ये समझना होगा कि hysteresis क्या होता है. So hysteresis is nothing But when we apply a magnetic field to a ferromagnetic material and then we reverse the direction or we remove the field, then also the magnetism is left in that ferromagnetic material. Some amount of magnetic field is retained by it. So in order to make it to the zero, the field is applied in the reverse direction, and then after applying in one direction and in reverse direction, a curve is traced, which is a closed curve. That curve is called as hysteresis loop. It means when a ferromagnetic material is applied to an alternating magnetic field, then a curve that is traced by that material, that curve is called hysteresis loop. Now we plot this curve between the flux density and magnetizing force. So if we start from this 0 point, or you can say origin, then in the starting or in the first half, or as soon as we apply the field, then it will trace a non-linear path and it will start from the origin O to the point A, and that point A is called as a saturation point. So between these O and A, the flux density, that is B, lags behind the force, okay, magnetizing force H. So it is a non-linear path. Now at A, इस पॉइंट पे क्या हो जाता है, saturation आ जाता है. Saturation का मतलब ये होता है कि all the materials are aligned in a particular direction and further magnetization or the alignment is not possible. So it reaches to a saturation point. Then if we reduce the force, okay, H को अब हम क्या कर रहे हैं, reduce कर रहे हैं, x एक्सिस में है, इसको आप वापस लेकर के आएंगे. जब आप इसको जीरो कर देते हैं, यहां पर आएगा at point B, here at point B, H is equals to 0, means we don't have any field applied to it. The magnetizing force is 0, but still you have the flux density, that is OB, and that OB is called retentivity. Now what is retentivity? So retentivity is that property or that amount of magnetism left behind the material when the applied field is made to 0, and that is also called as the residual magnetism. Okay, so retentivity is at from point O to B. Now we have to remove this retentivity or this magnetism further, or we have to make it to 0. So in order to make it to 0, it is not possible to go beyond this curve. We have to return to the negative half of H. So we just reverse the direction of the magnetizing force, and इसमें नेगेटिव हाफ H में चलते हैं. तो नेगेटिव हाफ H में जब हम जाएंगे from B to C, then at point C the H, that is magnetic force, is reduced to 0, or residual magnetism is also lost. So now there is no flux density in the material. The flux density is 0, but it has this much, that is OC. OC is the, you can say, this much of the strength or the force, you can say, and that force is called coercivity. Now that coercivity is very important to determine the type of material. How? Coercivity is that amount of energy required to reduce the magnetic flux density to 0, and if the coercivity of a material is high, okay, so the energy required is very high, so it is a good material, means the coercivity is high or it may be low. So for a soft material it is low, and for hard material it is high. Okay, so now we further increase the flux density, or you can say we follow the path from C to D. So in this path the H is negative again, and now B will also be reversed. Okay, the flux density will also be in the opposite direction, and here at point D again a saturation is reached, which is just opposite of the point A saturation. Okay, if it is aligned in the one direction, then in at D point it is just the opposite of the point A alignment. Now we go further, increasing the you can say increasing the value of your H, that is force. So here we come to point E, and at point E you can say the H is equals to again 0 here. Okay, likewise B we have H is equals to 0, E also H is equals to 0. Now the same path will be traced as from B to C and likewise from E to F. So we have found a curve that is a closed loop curve, and this particular curve is called the BH curve or the hysteresis loop. So A, B, C, D, E, F, A, this whole loop is called, or it's better called as the hysteresis loop. Now we have two more diagrams, or you can say two more figures which I have made. So this particular figure where the BH curve area, see this is the area of the BH curve and it is very narrow, and just now we have learned that narrow BH curve area is for soft material, magnetically soft material, and the energy, magnetic energy stored is also less. Okay, and for hard material obviously it will be a rectangular path I told you, and it will be a wider, okay, wider, and it is for the hard material. So this is the BH curve for your soft material, and this is the BH curve for your hard, magnetically hard material. So the BH curve is very important curve in magnetic circuits, so you have to learn it. And if you have any question regarding this whole topic which I have taught you, so please do comment in the comment section. So we will meet in the next class with a new topic. All the best to all of you.